So today we're going to be looking at inscribed angles, which is the angle inside of the circle when two boards connect at a single vertex on the circumference of the circle. And we're going to also be finding the intercepted arcs. Okay, so the angle of this arc right here that has a relationship with this angle, the inscribed angle. So let's take a look at that, because I see a lot of you are struggling with this. So we're going to view this topic real quick. For example, notice I have another circle here, right? And it's labeled A, C, and B, with C being the vertex where the two chords come together and create an angle. And this is actually an inscribed angle right here that I see. So I'm going to go ahead, I'm going to highlight it yellow. This is my inscribed angle. I'm going to write that in there. And then we have an intercepted arc on the outside. So for instance, this arc that you see right here, we're going to call that the intercepted arc. Now, both of these have a relationship, and the relationship is the angle of ACB, which is our inscribed angle. So I'm going to write that. The measure of is going to be equal to 1/2 the measure of the arc, intercepted arc, AB. So this is the formula that we're going to use to be solving these. And sometimes we're going to have the angle, right? So like ACB, we'll have that angle, that inscribed angle. And sometimes we're going to have the intercepted arc. And we're going to use those kind of back and forth to substitute either for this angle on the left, the inscribed angle, or the intercepted arc. On the other hand, if I were to draw what we call a central angle, I would go from the center of the circle and I would draw a line that goes to, or the point, I should say, that you see on this intercepted arc. So if I were to do that, and I'm going to demonstrate that real quick right now. This central angle here, and I'm going to write right here, this is the central angle, would be equal to the intercepted arc. But notice, you can tell by looking at it that this central angle here is much larger than the inscribed angle that's further back. This angle is smaller, this one's larger. And therefore, the intercepted angle is always going to be half of the intercepted arc, or the central angle. Or you could look at it and recognize that the intercepted arc, which is the central angle, will be double the inscribed angle, right? Notice this is bigger, so it's not just bigger, but it's always double this inscribed angle. So the intercepted arc's measure is equal to the central angle. With that all in mind, we're going to go ahead and solve this problem now. So take a look. Notice this one right here. I notice I highlighted it, right? We have an inscribed angle represented by the variable x. So you could look at this problem as they want you to find x. Now, they may write it a different way. Many of the worksheets that I've seen is, instead of them saying to find x, they'll say something like find the measure of LKM, right? And that's because this angle is represented as LKM as well. So whether you're finding x, which is this inscribed angle, or you're trying to find LKM, it's going to be the same process. Now, we're going to use that formula that you seen me write just a little earlier. We're going to find x first, and then we'll use that same formula to find our y value. So I'm going to go ahead. I've been given this measure up here, right? And this 40 degrees is the measure of the central angle. And so I'm going to go ahead, or you could also call it our intercepted arc measure. And I'm going to go ahead and write out the formula that we had previously. And in this case, I'm going to use the lettering that we have here. So I'm going to say LKM. So I'm going to write that out. So the measure of angle LKM, also known as x, right? It's that angle x, is going to be equal to 1/2 the measure of this arc L to M. Now that I got this written out, I'm going to substitute the numbers that I have. So we don't know what this measure is. We're trying to find it, right? We're trying to find the inscribed angle. But I do know this intercepted arc's measure, which is 40 degrees. So I'm going to go ahead and replace this right here, this measure of LM, right, that arc. I'm going to replace that as 40 degrees and put it in parentheses because we're going to be multiplying to it. I'm then going to go ahead and bring down this 1/2. And this is all equal to the measure of LKM. Now, if I put that in the calculator, and I know a lot of you are looking at it going, Mr. H, we could do that in our head. Well, that's fine. You can do it in your head. But Mr. H likes using the calculator. So I'm going to go ahead, hit alpha y equals, enter. Put in my fraction, 1/2. And then I'll put my parenthesis, and I'll put 40 in there. Hit enter, and notice it gives me 20. So my answer to this problem is the measure of angle LKM is equal to 20 degrees. So right here, I'm going to go ahead and write this is 20 degrees. Now remember, I told you that the inscribed, right, and one of the things I mentioned was that this inscribed angle, if you double it, it'll be the measure of your intercepted arc. So you can see that, right? 2 times 20 is 40. Now I'm going to go ahead and use the formula once again, just so you can see how it's used, and we're going to solve this bottom portion, right? Right here, we're going to solve for y. So now we're going to be solving, we're given an inscribed angle, but we're going to be solving for the intercepted arc's measure. All right, so now I'm dealing with this angle right here. So I have ONP. So I'm going to put right here the measure of ONP is equal to 1/2 the measure of my arc, which is going to be OP. So I'm going to substitute the values that I know. Now we don't know what the arc is, right? That's what they want us to find. It's represented by the variable y. But we know the inscribed angle is 50 degrees. So I'm going to go ahead and replace this angle right here with 50 degrees. And this is equal to 1/2 the measure of arc OP. Now what I want to do is I want to get the 1/2 away from the measure, right, of arc OP. So in other words, imagine this is being multiplied to this, right? So I'm just going to go over here and I'm going to divide it out. Divide by 1/2. Now this cancels, and I'm simply left with, and I'm going to kind of flip it around. I'm going to write this measure of OP. I'm going to write it right here. The measure of arc OP is equal to whatever I get when I divide 50 by 1/2. So I'm going to put that in my calculator real quick. So I have alpha y equals, enter, and 50 divided by 1/2. And notice it gives me 100. So that angle is going to be 100 degrees. The measure of the arc is going to be 100 degrees. So I'm going to put right here, y is equal to 100 degrees. Now the other thing is, right, I'm showing you how to do this algebraically. However, you could have just remembered that this inscribed angle is always going to be double the measure of the intercepted arc. So if you were thinking of it that way, you might have just said in your head, well, 2 times 50 is going to give me 100. So this is how you would show your work and do it algebraically, right? But you could always just double it. Or vice versa, if you have the measure of the arc on the outside, right, you have that in degrees, you can just divide that by 2, and that'll give you your inscribed angle. And that's all there is to it.